Okay, so let's now go to, actually, let me go back to my slides here. Okay, so we connected to the SIMC, the serial over LAN. So we said scope serial over LAN, then connect host. This is dropping us off on the OS of the APIC. Okay, then to reboot the APIC, I said erase config setup. This again is just like write erase. Then for the leafs and the spines, I connected to the console of them. So they have a regular console port, is a Nexus 9K, just like a whatever Catalyst switch does. Setup-clean-config.sh, that's the equivalent of write erase. Okay, then reboot, yes, afterwards. Okay, so now we're at the GUI. Okay, first tab, system, is where it drops you off by default. What this is showing you is just kind of overall umbrella picture of what the entire topology is doing. And the system uses what's called a health score. It's a rating of 0 to 100, where if you're at 100%, everything is good to go. Okay, you'll also see it color-coded, that if the object is green, then its health score is 100%. If it drops below that, it goes to yellow, and then if something really bad happens, it goes to red. Okay, red would be like the power supply failed on the box or something like that. But normally when you log in, it's going to show essentially nothing because there's no nodes configured. Okay, system health says there's no stats. Okay, so this is where you would go like under system controllers. This shows the details of the APIC itself. So there's node 1. And if we see under the hardware details, it says it's available, it's fully fit. It gave itself an IP address of 10.0.0.1. If we wanted to add another controller, this is where we would do it. So we would go under actions, change cluster size, and then whatever new, how many controllers that you have. Okay, so again, that's under system controllers, APIC, cluster as seen by node, and then under actions. Okay, if we go under interfaces, this will show like the ports. Okay, Ethernet 2.1 to 2. These are the 10 gig interfaces. ETH 1-1, this is the out-of-band management port that we're connecting through. Okay, if we go under the details of the node, it should show the physical view. Okay, so probably I could have just used this instead of that software release note. But this is what the box physically looks like. Okay, if we go to the front view, nothing special. Okay, it's just a C220 server. Okay, the next thing we're going to do is to tell it to find the leafs and the spines. So if we go under the Fabric tab, Fabric is the physical functions of the topology. And under here, there's two main categories. There's going to be Fabric policies and access policies. Now, if you think of the physical topology where we first have the APIC that is plugged into the leafs. So in our case, we're going to have leaf 101 and leaf 102. And then leaf 101 and 102 are plugged into spine 201. Okay, these are just arbitrary numbers that we're going to give to them. But if we think about what's going on here between the leaf and the spine, this is the underlay of the topology. Okay, in the underlay, this is where ISIS is running. This is where PIM is going to be running for multicast. This is where the COOP protocol is running in order to track where the endpoints of the VXLAN tunnels are. This is where we have our loopback addresses that we're trying to route to for the VTEPs. So anything that is related to the underlay, that would be considered a fabric policy. Like if we want to run multi-protocol BGP from the leafs to the spines in order to exchange IP routes over the fabric, then we would configure that as a fabric policy. The second section, which is the access policy, is going to be from the leafs southbound to the access devices. So think about just like you would do in Catalyst or Nexus. You say switch port mode access, switch port access VLAN 10. That from a physical point of view is going to be anything that's on the leaf going down. So this is going to be our access policy. And then northbound of the leaf is going to be the fabric policy. So of course, we're going to come back to this in much more detail later about what are the different things that we can do in the fabric policies. Like this would be if we were to go under pod policies. This is where we would turn BGP on. Okay, or you could do like ISIS customization. Then under access policies, this is going to be where the downstream links are. Okay, so what are the different switches? Right now, we don't have any switches yet configured. Okay, so there's nothing listed under there. So what we're going to do is go to inventory, and then under pod 1, this is where we do the fabric discovery. Okay, so right now it says that system-wide there's a fault. Okay, if we double click on this, and it says that there's 2 different faults. Okay, they have a different severity, which if you double click on this and it's going to show you the specific details, it says that the problem is that Ethernet 1.2 is down. Okay, this is talking about Ethernet 1.2 on the controller. So it means that from like a management redundancy point of view, if your out-of-band management port goes down, then you lost connectivity to the APIC. So ideally, you would dual connect this to your out-of-band management switch so that there's redundancy between the interfaces. Okay, so under Fabric Inventory, under Fabric Membership, this is where it's going to list what are the physical nodes that belong to the topology. Okay, we can see right now it discovered one of the leaf switches. It says the leaf is 9372PXE, which is the 48 port, 10 gig box going downstream, and then it's got 40 gig uplinks. So if we search for this particular part number again, it is 9372PX-E. This box physically. Okay, so the 40 gig ports here, these are the ones that we're using as the uplinks to the spines. And then these are the 10 gig access ports that are going down to the end hosts. Okay, so it looks just like a 5K fabric extender, the same. But the point being is that we've auto-discovered it. Okay, so what I do know already here is the serial numbers of each of the physical boxes. And the reason I want to know this is I want to make sure my numbering convention is the same that I configure in software versus how I have it physically racked in the topology. So when you're doing the initial discovery, it's the same as like you're doing for a fabric extender on the 5Ks or 6Ks, 7Ks. If you don't know what the serial number of the box is, there's no real way to tell from the CLI or from the GUI what physical box are we actually talking about. So if I have someone physically in the data center that has labeled this switch 101, like they print out a physical label, stick it on it that says switch 101, and then I go to the GUI and I label this as 102, it's going to make it that much more confusing from my configuration and verification. What box am I actually talking about? Okay, so if we go back to our diagram and we look at the topology we're going to be using, leaf 1, I'm going to be numbering this from our configuration point of view as leaf number 101. Leaf 2 on the left, we're going to number this as 102. The spine, we're going to number it as 201. This means from a port numbering point of view, this interface going to 7K1's port 1/7 is going to be Ethernet 101/1/1. Okay, just like a fabric extender would be on Nexus 5K, 7K. But the problem is that from the Apex GUI's point of view, it doesn't really know what does that serial number relate to. So you would already have to know based on your physical inventory what serial numbers are in which physical top of racks. Okay, because otherwise you can end up numbering the boxes wrong. And in my particular case, let me see here, I need to pull up my physical topology list. So the leaf 101, the serial number ends in RRMD, and then leaf 102 ends in R22Y. Okay, so let's see which one it discovered, because the APIC is plugged into both of them, is what the issue is. So let's go back to the GUI, and it says RRMD. RRMD was my leaf 101. Okay, so I'm going to give it that name. So you double click on this. We give it an identifier. I'm going to call this leaf 101. And the name I'm going to give it is leaf 101. You could call it whatever you want, but it makes sense to name it based on the node ID. So then you would know from a naming convention what is the port numbers. And then rack name, you can give some description for it. Okay, but this doesn't have anything to do with the config really. It's just a description of the device. Okay, so we're going to update this, and then what we should see happen is that it's going to assign it an IP address. And if we go, I probably should have done this before, is we go to the CLI, I am connected to the console of Leaf 101. Okay, notice on Leaf 101 it says none here. This is the host name. So what's going to happen in a second here is that once the APIC does the full discovery of the box, it's going to push the config down to it. So we should see that this field is going to change to Leaf 101, and then we can log into the CLI of the Leaf. Okay, from there we can run our regular show commands that we would do in Nexus. Okay, so you can see now it says Leaf 101. So let's log in as admin. And unfortunately here there's no show run. Okay, but you can run other show commands. So we'll come back to this in a minute because we don't really have anything configured. But if we open up this screen a little bit here, let me try to scroll this over, which is under the field I want to see here is the IP address. Okay, it said it assigned the Leaf the IP address of 10.0.144.127/32. It's essentially a pseudo-random address, but what this is really talking about is loopback 0. This is the VXLAN tunnel endpoint, or the VTEP address that's going to be used for all of the traffic that's terminating or coming from that particular box. So it's the same exact thing as we had done manually on the 5Ks. I went to loopback 0, I said IP address 1.1.1.51/32, but the APIC is doing this as part of its automation scripting. That it found the box, it logged into it, it configured an IP address, it configured IP at the interface level, it's running Link Local Discovery Protocol, or LLDP, and then from the Leaf, it figured out, hey, I'm connected to a spine. The spine's number is 9336PQ, which again is that fixed form factor spine, or what's sometimes referred to as baby spine. So I'm going to double click this. I'm going to say that this guy is node ID 201. And its name is going to be spine 201. And again, these are arbitrary. They could be whatever. It could be 1, 2, 3. But the naming convention starts at number 101. That's the minimum field. Then update. We should see if we go to the spine. So let's go to the CLI of the spine, which is this guy here. And we should see the same thing is going to happen, that it's going to change its host name from none to spine 201. And then we would be able to log into it. Okay, there's a question, does the IP address have anything to do with in-band management? Yes. Okay, so when we go to the APIC, we're going to issue the command bash, which drops to the bash shell. From there, we say show fabric membership, and it's going to show what are the different boxes that physically make up the topology. So in our case, it'll be Leaf 101, Leaf 102, and Spine 201. From there, we can SSH to those IP addresses in order to connect to the boxes. So in my particular case, I have multiple ways that I'm plugged in. I'm plugged into the console from my serial access server, which is why I can see the box with no config to begin with. And then if I hit enter again here, it should now change to Spine 201 because it fully configured it. Also, if we notice now, it has the third node. Right now it has node ID 0, but we can see it's another Leaf, 9372PXE. We double click on this. I'm going to give this number 102. Say this guy is Leaf 102. Update. And then if we go back to the console, Leaf 102, it will be configured when we see the host name change. And this is just a one-time thing. Once you've done the discovery, it's done. Okay, you only need to do this again if you're adding nodes or removing nodes. Like if the box crashes, you need to RMA it, put it back in. Then you would re-acknowledge it, give it that number, and then any configuration that the APIC already had that's corresponding to that Leaf automatically gets pushed down to it. So it's not bound directly to the box, which is kind of interesting compared to other normal configurations. Like let's say you have a 5600, that's your leaf switch, or top of rack, and it crashes. When you buy the new one and you replace it, you have to copy and paste the config into it in order to get the box back running. It's not going to automatically know its config by learning it from the other switches. But in the case of ACI, it does, because the APIC is the one that is the central management plane that has all of the configuration. Then based on the naming convention of me calling it node 101, that's what pushes all the config down to it. Okay, so we'll see that since we are making the changes from the APIC, but the configs are actually being pushed down to the boxes in hardware. And there's a question: what protocol is it using for discovery? It's using LLDP, Link Local Discovery Protocol. Just like it's like CDP, but it's the open standard version of it. Okay, so now we know about the two leaves and the spine. So if we go back under Fabric Inventory, and let's go to topology. Okay, this shows what the APIC is seeing as the physical view of the network. That the APIC is plugged into leaf 101 and 102. Leaf 101 and 102 are plugged into spine 201. If we double click on any of these boxes, it's going to bring us to the specific inventory of that box. Okay, this is the spine. You can see the spine is a 2U box, and it's got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24, 26, 28, 30, 32, 34, 36, 38. Is that right? 38. I thought it was 36. I must have miscounted. But these are 40 gig ports. Okay, you can see based on their kind of rectangular as opposed to square, where the SFP pluses are more like a square optic. These are the QSFPs, which are the 40 gigs. So if you open this up, you can see more details about it. Like what's the MTU? Okay, 9150, so it's going to be basically max frame size. You can see the physical ports. So if we look back at the topology diagram that we're using, the spine, I have this just on port 1 and port 2. So if we go back to the inventory and then go under E1/1, this is going to be the sub-interface that it's using to discover the other boxes. Okay, now let's look at this from the CLI point of view. So what I'm going to do now is to go to my regular local. So I'm not going to do this through the console. We don't really need to do anything from the console. I just wanted to show that when it makes its change in the host name, that tells you whether it's configured or not. Okay, so we're going to go from, let's say, one of the 5Ks. Okay, you could do this from your jump box like in the rack rentals, but you can also do it from any of the 5Ks or 7Ks that you're connected to. Okay, so I'm going to connect to 5K1. From here, if we look at the show IP interface brief for VRF management, management address is pre-configured as part of our scripting. So this box is 192.168.0.51. I had given the APIC .4. So if we do a ping to 192.168.0.4 in VRF management, I should be able to hit that box. Okay, we're now going to SSH to it. So I'm going to SSH admin at 192.168.0.4. VRF is management. Okay, put the password that I had created. Now we're at the APIC CLI. Okay, from here, we're going to say bash and then show fabric membership. Okay, and you can do tab for context-sensitive help. Okay, you can't do a question mark. Member question mark says invalid command. But if you say member and then you tab twice, it does do command completion. Okay, this is basically the same as the inventory output that we were looking at on the GUI, but it tells us what's the serial number, what's the node ID, and then what is the IP address of the box. So from here, if I was to say attach and then the name, attach leaf 101, and it is case sensitive, what this is doing is SSHing to that address. Okay, the password is going to be the same as whatever your user you're logged in as. So I'm logged in as admin, so it's the password for the admin user. From here, we're now connected to the NXOS CLI of the leaf. Again, you cannot see what the config is. You can't show run because the configuration is not saved on the leaf itself. It's saved on the APIC, but we can see the state of the network. So let's say that we wanted to look at the global routing table. Normally what you would do on Nexus or Catalyst or regular route is just show IP route. Okay, incorrect command though. So what we're going to do here is to do tab as opposed to question mark for context sensitive help. Okay, so if I hit tab, it says there's 1,500 possibilities. No, I don't want to show all of those. Okay, let's say show tab. You can see that there's a much smaller subset than you would see in a regular Nexus about what you can verify. Okay, I want to see IP information. Show IP, tab. Okay, so show IP, tab. I want to show IP route. So R tab, it's going to complete it. Show IP route for, let's say, VRF. Show IP route, VRF. And I hit tab again, it auto-completed, which was VRF all. Keep hitting tab, and then you can see what the other options are, like detail. Okay, otherwise, let's just hit enter. Show IP route, VRF all. Okay, it says there's a VRF black hole. Black hole, okay, hopefully self-explanatory is if you want to drop traffic. Okay, if you want to like quarantine something, you can put it in there. But the routing table here, VRF overlay, which is really confusing. They should have named this underlay. This is the VRF that the control plane is running in behind the scenes. The overlay is really the VXLAN tunnel. This is the source of the overlay, okay, which is really the underlay. Okay, but if we notice here, what's in there is IP addresses that are in the 10 network. That was the tunnel endpoint address, or the TEP addresses, that it asked me as part of the initial setup. So I just chose their defaults. I said, you give me the 10 network. And then if we look at specifically what is in the routing table is ISIS routes. Okay, the process name by default is ISIS_infra. This is part of the tenant that is called infra, okay, for infrastructure. This means that this is the magic that's going on behind the scenes that you normally don't need to touch. But the process is still there, just like it is in Fabric Path. You're running ISIS behind the scenes, and what it's trying to do is to solve the shortest path tree between all of the nodes. In our case, the nodes are the leafs and the spines, and the node identifiers are going to be the loopback 0 address that is going to be the VXLAN tunnel endpoint.